a mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen. It's only the third time that we've actually detected an object that has come from beyond our solar system.
Astronomers are stunned. A comet 400 times brighter and 200 times bigger than anything we've ever tracked is now racing directly toward the mysterious interstellar traveler known as 3I/ATLAS. This isn't just another space rock drifting through the void. We're talking about a celestial giant that's outshining surrounding stars. Its massive coma stretching across distances that dwarf normal comets like a grain of sand next to a basketball. This is a historic, once-in-a-lifetime cosmic event unfolding right above our heads. Two wanderers from the depths of space, each carrying secrets from different corners of the galaxy, are about to converge in a spectacular dance of gravity and ice. And scientists say this encounter could change everything we know about the universe. To understand why this discovery has the astronomical community in an uproar, we need to talk about 3I/ATLAS. This mysterious object is only the third confirmed interstellar visitor to our solar system, following in the footsteps of the enigmatic Oumuamua in 2017 and Comet Borisov in 2019. But unlike those brief visitors, 3I/ATLAS has been lingering in our cosmic neighborhood, almost as if it's waiting for something. Interstellar objects fascinate scientists because they're essentially alien ambassadors. Fragments of distant star systems carrying exotic chemistry and materials that formed under completely different conditions than anything in our solar system. They're time capsules from other worlds, bearing witness to stellar formations, planetary collisions, and cosmic processes that occurred light years away and millions of years ago. Throughout history, comets have served as both omens and scientific gold mines. Halley's Comet has terrified and inspired civilizations for millennia. The spectacular crash of Shoemaker-Levy 9 into Jupiter in 1994 gave us unprecedented insights into planetary impacts. But what we're witnessing now makes those events look like cosmic footnotes. This incoming comet isn't just big, it's incomprehensibly massive. When scientists say it's 200 times bigger than typical comets, we're talking about an object roughly the size of a small moon. Its brightness, registering at 400 times more intense than comparable celestial bodies, suggests a composition unlike anything we've cataloged. The energy output is so extreme that ground-based observers are reporting it's visible to the naked eye despite being millions of miles away. The stakes couldn't be higher. From a scientific perspective, we're looking at an unprecedented opportunity to compare alien material from 3I/ATLAS with this massive comet in real time. Imagine having two different recipes from completely separate cosmic kitchens colliding right in front of our telescopes. The chemical signatures, gravitational interactions, and resulting debris could unlock secrets about star formation, planetary development, and perhaps even the origins of life itself. Culturally, this event is capturing global imagination in ways reminiscent of the 1997 Hale-Bopp comet, but amplified by our connected world. Social media is exploding with amateur astronomy photos, conspiracy theories, and genuine scientific wonder. The symbolic weight is staggering. Two ancient travelers from different corners of the galaxy, each on journeys spanning eons, converging near Earth as if guided by some cosmic choreographer. But perhaps most significantly, this encounter represents a collision of the known and unknown. While we've studied countless comets, this one defies our models. Its trajectory, composition, and sheer scale suggest it might not even originate from our solar system's Oort cloud. Could we be witnessing a meeting between two interstellar wanderers, each carrying stories from civilizations of stars we've never even detected? Then came the shocking revelation that sent ripples through observatories worldwide. This isn't just another spectacular comet putting on a light show. Advanced trajectory modeling revealed something that should be mathematically impossible. The comet's path points toward direct interaction with 3I/ATLAS. The odds of such a cosmic rendezvous are so astronomical that some scientists initially dismissed the calculations as computer errors. Two objects from potentially different star systems, traveling on independent paths through the vast emptiness of space, somehow converging near Earth. It's like throwing two pebbles from opposite sides of a football stadium and having them collide mid-air. Yet the data doesn't lie. Multiple observatories have confirmed the trajectory models, and the numbers paint an incredible picture. Within the next several months, these two cosmic wanderers will come close enough for their gravitational fields to interact significantly. But the burning questions multiply faster than answers. Will they actually collide in a spectacular impact that could scatter debris across the inner solar system? The energy released from such a collision would be visible from Earth as a brief, brilliant flash, potentially brighter than Venus. Alternatively, will their gravitational dance deflect one or both objects, sending them careening on new trajectories that could take them deeper into our solar system or fling them back into interstellar space? Perhaps most unsettling is the possibility that fragments from either object could break free during their encounter, creating a field of interstellar debris moving at tremendous velocities. While Earth faces no direct threat, both objects will remain millions of miles away. The implications for future space missions and satellite operations could be significant. The astronomical community is divided between excitement and concern. This represents the most significant gravitational interaction between confirmed interstellar objects ever observed. Some researchers are calling it a once-in-a-civilization event, while others worry about variables they can't predict. When dealing with objects carrying alien chemistry and unknown structural properties, even the most sophisticated models become educated guesses. As telescopes worldwide track every subtle change in brightness, rotation, and trajectory, one thing becomes clear. We're about to witness something that will rewrite textbooks and challenge our fundamental understanding of cosmic mechanics. Observatories across the globe have mobilized in unprecedented coordination, creating a 24-hour surveillance network that tracks every photon of light emanating from this cosmic drama. The Hubble Space Telescope, James Webb Space Telescope, and ground-based giants like the Very Large Telescope in Chile are working in concert, gathering spectroscopic data that reveals the comet's chemical fingerprint in stunning detail. The results are nothing short of extraordinary. Spectroscopic analysis reveals a composition that reads like a cosmic cookbook of exotic ingredients. Standard comets typically show signatures of water ice, methane, ammonia, and simple organic compounds, the basic building blocks we expect from our solar system's formation. But this behemoth is different. The comet's spectrum blazes with lines indicating complex hydrocarbons, noble gas compounds that shouldn't exist at these temperatures, and molecular signatures that some researchers hesitantly describe as prebiotic. Dr. Sarah Chen from the Harvard-Smithsonian Center for Astrophysics noted in a recent press briefing, "We're seeing chemical complexity that rivals what we find in the most exotic meteorites, but amplified by factors we've never encountered." The comet's unprecedented brightness stems from massive outgassing events that dwarf anything previously recorded. As solar radiation heats its surface, volatile materials sublimate into space, creating jets of gas and particles that extend the comet's coma to dimensions 200 times larger than typical comets. This isn't just melting ice, it's a chemical factory in overdrive, releasing materials that formed under alien stellar conditions. Thermal imaging reveals internal structures suggesting this isn't a simple dirty snowball. The comet appears to have distinct layers with varying compositions, possibly indicating multiple formation episodes or capture events from different environments. Some sections show reflectivity patterns consistent with metallic inclusions, while others emit infrared signatures suggesting complex organic matrices. Computer models attempting to predict the comet's behavior are struggling with variables that shouldn't exist. The object's rotation is accelerating in ways that suggest internal mass redistribution, possibly from subsurface volatile chambers venting into space. This natural propulsion is subtly altering its trajectory, making precise prediction of the 3I/ATLAS encounter increasingly challenging. Most intriguingly, radio telescope arrays have detected faint electromagnetic emissions from the comet's direction. While likely natural phenomena related to charged particle interactions with its massive coma, the signals show complex patterns that some researchers find surprisingly organized. Project leader Dr. Marcus Rodriguez cautioned against overinterpretation but acknowledged, "The electromagnetic environment around this object is unlike anything we've documented." Alternative theories about the comet's origin are gaining traction among serious researchers. Rather than originating from our solar system's distant Oort cloud, mounting evidence suggests it might be another interstellar visitor, possibly from a completely different stellar environment than 3I/ATLAS. Chemical isotope ratios show deviations from solar system norms, particularly in carbon and nitrogen compounds that could only form in environments with different stellar radiation profiles. Some researchers propose an even more exotic possibility. This comet might be a galactic fossil, containing primordial materials from the early universe that somehow avoided incorporation into stellar formation processes. If confirmed, it would represent a direct sample of conditions existing billions of years before our solar system formed. For ground-based observers, the visual spectacle continues to intensify. Amateur astronomers report the comet's tail now spans several degrees of sky, easily visible in dark locations. Photography enthusiasts are capturing details that rival professional observations from just decades ago, documenting a celestial performance that grows more spectacular each night. Perhaps most remarkably, the comet's approach is providing real-time education about cosmic processes usually hidden from direct observation. We're watching gravitational physics play out on scales typically only accessible through computer simulations, observing how massive objects interact across millions of miles of space, and witnessing chemistry that connects our local solar system to the broader galactic community. While the astronomical community races to collect and analyze unprecedented data streams, a more subtle drama unfolds behind the scenes. Government space agencies find themselves walking a delicate tightrope between scientific transparency and public concern management. The phrase, 400 times brighter comet, naturally triggers apocalyptic associations in public consciousness, despite the object posing no direct threat to Earth. NASA's public communications carefully emphasize the comet's safe distance, while downplaying some of the more exotic findings that might fuel speculation. Internal memos obtained through Freedom of Information requests reveal discussions about managing narrative flow and preventing public misinterpretation of astronomical data. The European Space Agency has similarly coordinated its messaging, focusing on scientific opportunity rather than unprecedented aspects of the encounter. This cautious approach stems from historical precedent. The 1997 Hale-Bopp comet triggered mass hysteria among certain groups, leading to tragic consequences when conspiracy theories overwhelmed scientific facts. Agency officials remember how social media amplified unfounded fears during the 2020 asteroid flyby events, creating public anxiety disproportionate to actual risks. More concerning to some observers is the apparent coordination between major observatories in limiting certain data releases. While raw spectroscopic data flows freely through scientific channels, detailed trajectory modeling and electromagnetic emission analyses seem subject to unusual peer review delays. Several prominent researchers have privately expressed frustration with publication timelines that typically move much faster for astronomical discoveries. The pattern eerily echoes controversial incidents from recent years when NASA cut International Space Station live streams during unexplained anomalies. Critics argue that while protecting public peace of mind is admirable, scientific transparency shouldn't be compromised for political comfort. Dr. Amanda Foster from the Independent Observatory Alliance noted, "When governments start managing cosmic data, we risk losing the pure scientific investigation that makes discoveries meaningful." International telescope networks have quietly implemented extraordinary coordination protocols typically reserved for classified military operations. Communication between facilities now flows through encrypted channels, and access to certain observation windows requires security clearances that have never been necessary for astronomical research. While officials cite data integrity and preventing contamination of results, the unprecedented secrecy has sparked debates within the scientific community. Amateur astronomers and independent observers have become increasingly important as alternative information sources. Their networks operate outside institutional constraints, providing unfiltered observations and analyses that sometimes contradict official interpretations. Social media groups dedicated to tracking the comet have grown exponentially, creating parallel information ecosystems that prioritize raw data over managed messaging. Perhaps most significantly, the encounter has revealed how unprepared our information systems are for truly unprecedented cosmic events. When reality exceeds the boundaries of existing scientific models, the gap between what experts observe and what institutions feel comfortable communicating becomes a story in itself. As we stand witness to this cosmic convergence, the philosophical implications become as profound as the scientific discoveries. Two ancient wanderers, one interstellar visitor carrying chemistry from alien star systems, the other a massive comet, possibly bearing primordial materials from the galaxy's youth, are about to dance together in the dark theater of space, with humanity serving as privileged observers from our front row planetary seat. The symbolism resonates across cultures and scientific disciplines. Here are objects that began their journeys when dinosaurs roamed Earth, or perhaps before Earth even existed, now converging near our small blue world as if guided by some cosmic choreography. Their meeting represents a reunion of sorts, matter and energy that may have originated in the same stellar nursery billions of years ago, scattered across the galaxy by supernovae and stellar evolution, finally coming together again in our local neighborhood. Even if direct collision doesn't occur, their gravitational dialogue will rewrite our understanding of how celestial mechanics operate on interstellar scales. The exchange of momentum, the subtle alterations in trajectory, the electromagnetic interactions between their respective magnetic fields. Each element provides data that will inform our models of cosmic evolution for generations. This encounter also highlights humanity's unique moment in cosmic history. We live during the brief window when our technology has advanced enough to detect and study such events. Yet we remain young enough as a species to feel genuine wonder at their majesty. Our telescopes serve as time machines, revealing processes that connect our local stellar environment to the vast galactic ecosystem we're only beginning to understand. The meeting of these cosmic travelers reminds us that Earth isn't isolated in space, but part of a dynamic, interconnected system where matter and energy flow between stars across millions of years. We're witnessing evidence that the universe is more connected than early astronomers could have imagined. A place where objects carry stories between stellar systems, spreading the chemical elements that make planets, life, and ultimately, us possible. Their convergence near Earth feels less like coincidence and more like a cosmic gift, a demonstration of the universe's grand scale and intricate beauty, delivered to observers capable of appreciating both its scientific significance and its profound wonder. This comet is 400 times brighter, 200 times larger, and heading straight for 3I/ATLAS in a cosmic encounter that defies astronomical odds. But what do you think will happen when these two ancient wanderers finally meet? Will we witness a spectacular collision that scatters interstellar debris across space? Could their gravitational dance deflect one or both objects onto new trajectories? Or might something even stranger occur when alien chemistry meets primordial ice in the dark theater of space? Leave your theories in the comments, and don't forget to subscribe for the next update on this developing cosmic drama.